So today we will be talking about transition metal ionics. Transition metals can change how many electrons they lose, so the charge, which we call the oxidative state, must be calculated every time. This makes transition metal ionics slightly hard to do, but still manageable. So for showing that they have an oxidative state, we have to use Roman numerals to calculate the charge. But before we get into all of that, I am going to show you where transition metals are on the periodic table. So transition metals are from here all the way to the end of the staircase that we have here. Everything in between are the transition metals. But there are some special transition metals that we don't have to calculate the charge of, and this is cadmium and nickel. Cadmium and nickel is silver, cadmium, zinc, and aluminum. They're kind of hard to remember, so we just remember as cadmium and nickel. Okay, so let's go to some examples on how to do this. For the first one, we have Fe2O3. So to find the charge is the first thing we do. And to find the charge, we must use the anion first. So how to find it is you have subscript times the charge equals the total charge. So subscript is 3, meaning that there are 3 oxygens. This is times the charge. So if we go over to our periodic table, we can find that oxygen is in 6A, which means it has a charge of -2. So 3 times -2 is equal to -6. The total charge of an anion and a cation are equal and opposite to each other. So we know that the cation has a total charge of 6. We also see that subscript is 2. So this makes it really easy for us to calculate its total charge, which would have to be 3, because 2 times 3 is equal to +6. Now that we know its charge, we have to determine what type of element it is. Fe on the periodic table is iron. So we keep its original name and give it iron. Then we put the Roman numeral for its charge. This is to give scientists info on what it is. The Roman numeral 3 is 3 I's. Next, we have to put the anion. If we go over, we find that O is oxygen. So, going with the last lesson, we're just going to keep the same rules. Instead of oxygen, we're going to take off and add ide. So it's going to turn out to be oxide. So our total thing is iron 3 oxide. That is its official name. Now let's go from the next one we will be doing is nickel to bromide. So first we have to get the element symbols. So nickel, if we go over to our chart, is Ni, and bromide is a secret name for bromine, which is Br. So we put Ni and Br. Now we have to find their charges. The fun thing is that we already know nickel's charge, which is +2. So you can put 2 plus. Bromide, over here, bromine, is in class 7A. Therefore, he only has a -1 charge. We then switch their charges to where nickel gets bromide's charge, which is -1, which we don't write because it's a 1. And bromide gets Nicholas' charge of 2. So we get NiBr2. That is all.